more examples of improper integrals that are fairly obvious as to where the discontinuity occurs. So we have this integral from 1 to infinity, e to the 1 over x divided by x squared. I think everybody can clearly see that this is an infinite discontinuity. All right. The only other place it could be not continuous would either be negative infinity or 0, but we don't have 0 within the domain. So we're going to write this now as our limit as c approaches infinity, same integral except from 1 to c of e to the 1 over x divided by x squared dx. Similar to the previous problem, this is a u substitution problem. I'm going to let u be equal to 1 over x, which is the same thing as x to the minus 1. Du is going to be equal to negative 1 x to the minus 2 dx. All right. And that's really the same thing as minus 1 over x squared dx. And that's almost what we have, right? The only thing that we have different is the negative. So what I'm going to do is I'm going to multiply both sides by negative 1. And we get that the opposite of du is 1 over x squared dx. All right. So now we're going to rewrite this as lim as c approaches infinity, change a variable. So we're going to have from a to c. All right. So we could still go towards infinity if we wanted to. Just to be really certain of this, we could go from a to b, just because when we substitute infinity back in, it may or may not go to infinity. All right. This is going to be e to the u and then negative du. Right. We could just go ahead and factor the negative out. We know the antiderivative of e to the u is e to the u. So we're going to get lim as c approaches infinity of minus e to the u from a to b. Or if we back substitute for u, which was 1 over x, we're going to get the limit as c approaches infinity of minus e to the 1 over x from 1 to c. And now we're going to go ahead and substitute the limits of integration back in. So we get lim as c approaches infinity of minus e to the 1 over c minus a negative e to the 1 over 1. All right. Now, think about this, guys, and don't think that this is going to go to 0, okay? When you substitute infinity back in, you get 1 over c. So this really now becomes negative e to the 0, okay? So be wary of that, okay? It's not just going to go away, and it's not just going to go to 0. It's going to become e to the 0. And this is going to be plus e to the first. And so we can really write this as e minus 1 as the precise value. Okay, so this is just going to be negative 1, and this is our e to the first power. All right, so pretty neat that we can get a precise value out of this limit. And it wasn't the prettiest looking integral to start with. Okay, of course, all of our techniques of integration are going to be required for us as we go through. So we have to keep in mind all of those techniques. All right. Another example, we have integral 0 to 3 dx over square root 9 minus x squared. All right, so clearly, if I substitute 0 back in, we get the square root of 9. That's okay. If I substitute 3 back in, I get 9 minus 9 in the denominator, which is going to be square root of 0. So that's no good. So this is actually the discontinuity right here for this one. So we're going to say that this is going to become the limit as c approaches 3, integral from 0 to c dx over the square root of 9 minus x squared. All right, now, this one, although it looks like, and we certainly could use a trigonometric substitution, the good news is, guys, this one is on the basic list of integrals. Okay, so if we pull up our basic list of integrals here, all right, and let me blow this up so that way we can see which one it is in case you're looking on your phone. We know that it fits this form. Okay, so it's going to be sine arc sine, or sine minus 1 of u over a. All right, in this case, u is going to be x and a is going to be 3. Okay, so this is going to work out to be the limit as c approaches 3. We're not going to do a u substitution or anything like that. So this is going to be arc sine of x over 3. All right, so right here, a squared is 9, which implies that a is 3. And right here, x squared is u squared, which implies x equals u. So we just plugged it back into our formula. And we're going to range from 0 to c. Right? If we go back, we're going to substitute the 3 back in because we know now we can substitute 3. Okay, so we're going to now get lim as c approaches 3 arc sine of c over 3 minus arc sine of 0 over 3. Right? And that just turns into arc sine of 3 over 3 minus arc sine of 0. And that's just arc sine of 1. All right. And sorry, I'm writing quickly on the screen. All right, so this is arc sine, and this is arc sine. All right. This is a 0. And then the 3 over 3 is a 1. All right. And so that means that we have to try to remember what the arc sine values are. Okay. So it might be helpful to have your unit circle. Okay. So here's our axis. Here's our unit circle. And we're looking at when the y value, so this is the point 1, 0, and then this is the point 0, 1. All right. And remember, the arc sine asks us what angle, so in other words, the sine of theta is equal to 1. All right. And in this case, theta is going to be pi halves, right? We can clearly see that when y is 1, the angle is going to be pi halves. And then for the arc sine of 0, well, that's going to be 0 radians or 0 degrees. Okay, so arc sine of 1 is pi halves, arc sine of 0 is 0, and so we end up with a pi halves for the precise answer. All right, so that's 2 more examples. Okay, obviously we're going to take a look at a few more as the videos progress, and they're going to be of increasing rigor.